Welcome to this video on graphing linear equations in slope-intercept form. By the end of this video, you should be able to convert a standard form linear equation to slope-intercept form. You should be able to identify the slope and y-intercept from a slope-intercept form linear equation. You should be able to plot the y-intercept on a coordinate plane, and you should be able to plot the slope on a coordinate plane. Alright, so with graphing, the slope is the rise over the run, meaning the change in y's over the change in x's of a line. For a line, it's constant, and there's 4 different kinds of slope that we can get. A positive slope means the line points upwards, left to right. We always read a graph from left to right. A negative slope will point down as you go from left to right. A zero slope means it has no rise at all. So it's a perfectly horizontal line. And an undefined slope is a perfectly vertical line. All it does is rise and it has no run. Okay, so these will be y equals mx plus b, both of these. A zero slope will be a y equals a number line. Whatever the number is, that's where it's going to go through the y-axis. And an undefined line will be x equals a number, whatever number the x-axis is crossed at. Right, so we have our slope. There's a bunch of different ways to say it. We've got rise over run, so we're talking the y value over the x value. Our vertical change over our horizontal change. So you're either going to go up or down when we count our slope, because that's our vertical change, and then you're going to count right. All right, so let's take a look at an example. So we have a scenario where we're buying posters online. They are $2 each. There is a shipping cost of $1 to send the poster to you. Graph the equation. I've given you the equation. Now, remember from the other day, when we graph, we like to be in slope-intercept form. This is currently in standard form. So slope-intercept form is y equals mx plus b. That means we need to have y by itself. So I'm going to isolate the y, I'm going to add 2x to both sides so I can get y by itself. Negative 2x plus positive 2x cancels to 0. And all I have on the left is y equals 2x plus 1. So remember, our slope here is the number in front of the x. So our slope will be 2 over 1. And my y-intercept is 1. We always start graphing at the y-intercept. It gives us a place to start. So y is 1 is right there. Okay. Now our slope, this is 2 over 1. Remember, this is a y value over an x value. Y values are up or down. This is a positive 2. So that means we're going to go up because positive y's go up over a positive 1, and positive x values go to the right. So this says we're going to count up 2 and right 1, and that's where our next point on the line will be. So we'll go up 1, 2, and right 1, and drop another point. Up 2, right 1, drop another point, and we just keep repeating the pattern. Now, what if I wanted to make this line just a little bit longer before I drew it? So I was counting up and right. I can count exactly opposite that in order to extend the line back over here if I felt like it. So instead of up 2, right 1, I'd go down 2, 1, 2, and left 1. Do you see how it still falls in line with the rest of the points? Down 2, left 1, down 2, left 1. So once I have enough points that I feel comfortable, I'm going to take my ruler and I'm going to draw my line. So draw it long, put arrows on both ends, and we've just graphed a line. Let's try some of these that are on the back. Alright, so we have a standard form equation, 2x minus 3y equals 9. Remember, we need to be in slope-intercept form, so we need y by itself. So we're going to move this 2x, so we're start isolating the y. Here's y in here. It can be the only term on that side. So we're going to subtract 2x from both sides of the equal. It cancels on the left, leaving negative 3y equals negative 2x plus 9. Now remember, we're trying to get y alone. This is negative 3 times y. So to undo the multiplication, we're going to divide. And you're going to divide every single term by negative 3. Okay. Negative 3 divided by negative 3 is going to cancel to a positive 1, leaving us our y equals. Now negative 2 divided by negative 3 will not be a nice whole number, so we're going to leave it as a fraction. But a negative divided by a negative gives us a positive, so 2/3 x. And then I have 9 divided by negative 3, which gives me negative 3. Okay, my slope here is 2 divided by 3, and my y-intercept is negative 3. So we're going to start at where y is negative 3, right here. And our slope, that's a positive 2 for the y value, so that means it's going to go up 2. That's a positive 3 for the x, so positive x's go right. So from this point, we're going to go up 2, right, 1, 2, 3. And drop another point. Up 2, right, 1, 2, 3. And drop another point. If we wanted to extend our line back in the other direction to help us draw it, we went up and right, so we're going to go down and left, which is the exact opposite. So down 2, left 1, 2, 3. And you can see that it's still in line. Down 2, left 1, 2, 3. Once you have enough points you feel comfortable drawing, we're just going to connect our points together, put arrows on the ends of them. All right, let's try another one. You are walking down a cliff in Death Valley, California. You are starting your journey 5 feet below sea level. The change in elevation is 1 foot for each foot you walk down the cliff. Graph the line with the equation x plus y equals negative 5. Okay, we're in standard form, so we want y by itself. We're going to move the x over, and we get y equals negative x minus 5. That's it. That's all we need to do. We've got y alone. There's no dividing we need to do. So our slope here is negative 1. And remember, any whole number you can place over 1 to kind of give us our rise over our run. And then our y-intercept is negative 5. So we're going to start at negative 5. 1, 2, 3, 4, 5, and put a point. Okay, our rise over our run, that's a negative 1 for the y, so that means that go down 1. That's a positive 1 for the x, go right 1. So we're going to go down 1, right 1, another point, down 1, right 1, down 1, right 1. Okay, if we wanted to go in the opposite direction to extend our line, we went down and right, so we'd go up and left, up and left, up and left. Okay, once you have enough points that you feel good about this, we want to connect our line. And we want to draw it further. It's longer than just what that shows. And then we're going to stick arrows on the end of it. All right, let's try this one last time. We're going to graph the line 4x minus y equals negative 8. That's standard form. We need to be in slope-intercept form. So we're going to subtract 4x from both sides of the equation. I get negative y equals negative 4x minus 8. Now I want positive y, so this is really a negative 1, so I'm going to divide each term by negative 1 to get the y alone, and we get y equals 4x plus 8. Our slope is 4, that's the y value, over 1, that's our x, and our y-intercept is positive 8. Okay, so we start graphing where y is 8. 1, 2, 3, 4, 5, 6, 7, 8. Drop a point. Now our slope, that's a positive 4. Positive for y's go up. That's a positive 1 for the denominator. That's an x value. X positives go to the right. So this says count up 4 and write 1. But I run out of room immediately. I don't have room to do that. However, remember we can always count opposite. We did it on all the other ones. So instead of up and right, we're going to count down and left. So down 4, 1, 2, 3, 4, right 1. Down 4, right 1. 1, 2, 3, 4. Once you have enough points that you feel comfortable making the line, we're going to connect these together. And we're going to put arrows on the end because that line does not stop. All right, well, hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.